Let's have a look at using a CNC router to make wooden signs, mill brass, cut cardboard templates, machine polycarbonate, engrave granite, and cut builder's foam. Before getting started, be sure to check the RPM of your spindle or router. In some cases, the RPM is 0. You'll also need to check the feed rate, the travel of the spindle or router, to make sure it's right. Check your owner's manual for how to do this with your machine, and have a look at the companion article that goes with this video for specifics on feeds and speeds. First, let's look at cutting letters and a design into this walnut board. The work is being done with a 60-degree half-inch V-bit. One of the things that's interesting, you'll see in our next project, we're going to use the same design twice with slightly different tool paths to get a different look. With the lettering and artwork done, I'm now using a 1/4-inch bit in order to cut the final shape on the outside of our sign. And here's the result. Same design, but different look coming at you here. In this case, the letters will be raised from the background. So we're starting with a 1/4-inch bit, and that's eliminating a lot of the background waste here. As you're choosing the cutter for this operation, keep in mind that a large diameter bit will remove the waste more quickly, but a small diameter bit, like this 1/4-inch, is better able to get into the detailed spots artwork like this has. Now we're back to that 60-degree half-inch V-bit, and this bit is going to cut in all of the details. Look how it leaves those letters stand proud of the background, giving this sign a very hand-carved look. I have made a lot of projects with this technique, but I still find it very intriguing to watch how the CNC machine controls the bit and allows it to create these very fine details. Now we're back to that 1/4-inch cutter again in order to cut the final shape and dimensions of this sign, just like we did on the last one. When you see the spindle lift slightly, it's leaving tabs behind, bridges that connect the work to the surrounding frame to hold it in place. Same artwork, different tool path, and a different look. The brass is being milled with a single flute 1/8-inch diameter cutter, making a bow tie that I'll put into a walnut table. Non-ferrous metals require a very light depth of cut, and notice here I'm finishing up with a climb cut in order to get the best possible surface finish on the brass. Double-faced tape works great for keeping the brass secure to a wasteboard. And I can't wait to get this project done. When you're using a drag knife, like we are here, set the spindle or router to 0 RPM, 0 RPM. Let me repeat that, 0 RPM. You don't run the spindle or router for this operation. What a great way to turn your project plans into templates that you can use in your shop. It's amazing how the drag knife will pivot as it's pulled through the material in order to cut pretty complex shapes. I clamp a melamine backer board to the CNC table and then use spray adhesive on top of the melamine to keep the cardboard secure. And these parts are ready to trace onto your project pieces. The 1/4-inch polycarbonate is being cut with a 1/4-inch single flute bit. And if you watch carefully here, you'll notice that the image has been reversed and is being cut into what will be the back side of the polycarbonate. This is a pretty common approach to see-through materials. This is a good time to mention too that dust collection on these CNC machines is great when the dust shroud is on, but in order to shoot video, I've got the dust shroud removed. With double-faced tape holding the polycarbonate in place, I'm cutting completely through on this pass, no tabs, to produce the final outside shape. And what woodworker doesn't need this in their shop? Here's another case where you'll set the spindle or router RPM to 0. You don't spin it for this. This is a diamond drag. There is literally a piece of diamond in the tip of this tool. When you set depth of cut on the diamond drag, what you're doing is controlling how hard the spindle pushes down on the compression spring and the tip. Harder materials require more down pressure. It's all very well explained in the instructions that come with the tool. This work can be done on granite, glass, aluminum, brass, steel, lots of different materials. I love the look. Yep, that's a piece of standard pink building foam right off the shelf at a home center. Because it's 2 inches thick, this provides a great way to test your cuts in a relatively inexpensive material before you throw a really expensive slab of wood onto your CNC. Or you can use it for what I'm doing here and create 3D artwork. The roughing out portion of the cutting is being done with a 1/2 inch end mill. That'll get most of the waste removed. The detail work is being done with a 1/2 inch round nose bit. That works here because the artwork is pretty good size. If you're working on a smaller piece, in order to get all your details, you probably have to go to a smaller diameter cutter. The final outside shape is being cut with a 1/2 inch end mill, same bit we did the roughing pass with. Again, I'll leave tabs behind to bridge the workpiece to the frame. A little bit of latex paint and we're good to go. Like driving your car, speed limits aren't just a suggestion, they're the law. When you're running your CNC router, you've got to pay attention to feeds and speeds to get everything to come out right.